So it says if this and this, so that and h of x is equal to this, then what's AB? So we're asked what's AB? So first of all, you say to yourself, okay, so I'm dealing with absolute value function. So I know in general an absolute value function has the form a times the absolute value of x minus h plus k, right? Where this is a slope for a absolute value function, but it's also a stretch or compression, right? And then this is our shift left and right, and we always go opposite, right?
Yeah.
This is our shift up and down, and our sign stays the same. So, it says, they even gave you an example as a hint. If this has a vertex, it doesn't say vertex, but that is 2, 5, because isn't this right 2 of 5? So wouldn't that be 2, 5 if we were to graph that? Okay, if 2, 5, then in this, what is AB? So now does the acceleration affect the shift? No, and there's nothing in front of x right here, so we're good. Like we don't have to factor anything out here, right? So we're all good to go. We can just determine what's our shift going to be on this. Left 1, down 2. So wouldn't that be -1, -2? Everybody good with that? Okay. Questions? Who got it right? Wow, yay, that's good. Okay, how many of you made an error? You see where you made it now? Okay, good. It's good that you see. Okay, let's get started. So we just started our unit with sequences and series, and we were dealing with sequences yesterday. So we're going to be dealing with specifically arithmetic sequences today. So, 8-2, here we go. You're going to need to take a few notes, guys. So, an arithmetic sequence has a constant difference or common difference between consecutive terms. We were seeing stuff like this yesterday. Today we're going to focus in on arithmetic sequence. So, once again, an arithmetic sequence has a constant difference or common difference between consecutive terms. Now, guys, when you see the word consecutive, it means one right after the other. So, when it says common difference, what we're going to be doing is we're going to be looking at our sequences, and we're going to be subtracting one term to the previous term, and we're going to see if there's a constant common difference between them. Now, when you're subtracting, you've always got to take the term that comes before the term above it. So let's look and see if there's a common difference here. So 6 minus 3. 3, right? Everybody. What's 9 minus 6?
3.
3. What's 12 minus 9?
3.
3. What's 15 minus 12? 3. So was there a common difference between these? Yes, because in between each terms aren't we adding 3? Okay, so we can say this is for sure arithmetic. And then the common ratio, guys, the common ratio is 3. Questions on that? So let's determine if this next one is arithmetic. Now, with arithmetic, it will always be the same from one term to the next. Never different. So let's check here. So we're going to find our ratios. So 4 minus 1. 3. What's 9 minus 4? What's 16 minus 9? 7. So we know right now it is not arithmetic, because arithmetic will be the exact same from one term to the next. Does that make sense, everybody? Okay, sweet. So we would say no, it's not arithmetic. There's not a common ratio. Questions on that? Okay, pretty straightforward then. So do 1 through 10. Make sure you read the directions. It says determine whether each sequence is arithmetic. If so, identify the common difference. When I said ratio, that would have been divide. Bless my heart. It's difference. It's a common difference. Right? Ratio is divide, right? It's not that big of a change. It's just I said divide, but it's not, we're not dividing, right? It's addition, right guys? Subtraction. So I shouldn't have said ratio, I said difference. Common difference was 3. Does that make sense, everybody? Sorry about that. Okay, so yesterday we saw a bunch of arithmetic sequences, and we had to personally write a formula, right? So, remember yesterday we learned there are 2 different types of formulas, a recursive and an explicit. So remember, in general, recursive is a formula written in terms of the previous term. So this is just an example right here. I mean, so like in terms of the previous term, h of n minus 1, remember n minus 1 means just previous term, right? And then we added something or subtracted something, right? With arithmetic. And then an explicit definition, remember explicit formulas have, they're in terms of n, which n stands for what term we're talking, right? So, like there was, for example, n plus 1, right? Or n plus 3. What? We're about to get there. Okay, so for arithmetic sequence. Today, I'm giving you the general formulas that will always work. You won't have to write your own because these are, some mathematicians went through, they came up with a proof, they figured out they were seeing a common thing happen here, and these are the formulas that will always work. So today you're not going to have to write your own. You're just going to use these, okay? Because for no matter what, they will always work. So, we're going to use, for the most part, an explicit definition to find any term. So, if it's an arithmetic sequence, just a second, that might be the office. Nope. So for an arithmetic sequence, this is the recursive definition. So, a sub n is equal to a sub n minus 1 plus d, where d is the common difference. That will always work for any arithmetic sequence. That's the recursive definition for it. An explicit definition. Now, once again, we can write our own, but in general, this will always be true. So, a sub n, you'll want to write this down. A sub n, and we mostly use this one to calculate because you have to know the previous term to be able to calculate a recursive definition. With an explicit definition, you don't need the previous term, so you can just easily calculate it. So the formula for any arithmetic sequence, an explicit formula is a sub n is equal to a plus n minus 1 in parentheses times d. So I'll tell you what each of these things stand for. A is just a sub 1, which means the first term in the sequence. Is everybody good with that? You'll want to write that down so you don't forget. A is just a sub 1. So really I could have just wrote a sub 1 in there, which just means the first term in the sequence. And then n is the number of term we're talking about. So if it was 43, we'd put in a 43 right there. Does that make sense, everybody? So it's n minus 1, and then d is the common difference. So the common difference between the terms. So once again, we could write our own explicit definition, or we could just say, I know in general this formula will always come out correctly. Does that make sense, everybody? Okay, sweet. So I just use this. If I know it's arithmetic, I use this formula because then I don't really have to think much. Okay, do we have this written down so we can just do some examples? It's actually pretty easy, guys. Okay, so it says, what's the 100th term in this arithmetic sequence? So first of all, you say to yourself, okay, if it's arithmetic, I know I can find any term using an explicit formula. I like the explicit formula because you don't need the previous term for that. So the explicit formula for an arithmetic sequence is a sub n is equal to a plus n minus 1 times d. So remember, a is a sub 1. Okay, so what is a sub 1 in this sequence? Good. So our a value is 6. So we have a sub n is equal to 6 plus, now n is the term we're talking, right? A sub n. So we're looking at a sub 100 is equal to 6 plus 100 minus 1. Isn't that n minus 1? And then d is the common difference. So let's look here. What's the common difference from one consecutive term to the next? So you're going to take 11 minus 6. 5. So our d is 5. So times 5. Now look, there's no more unknowns, right? So that's going to give us that term. So here we go. Type it in. Make sure you use parentheses where you see them. So 6 plus 100 minus 1, close your parentheses, times 5. Did you get 501? Yep. So a sub 100 is equal to 501, which means the 100th term would have been 501. So we wouldn't want to have to sit and add 5 100 times, would we? Do you get what I'm saying? Yep. Okay. Sweet. Okay, let's do this one, then I'll just let you work. It's that straightforward. It's not hard. So it says, what's the 46th term of the arithmetic sequence? So you say, okay, I know in general, we could write our own, but I'm just going to use the explicit formula that always works for any arithmetic sequence. So what's our a? So we want a sub 46, right? That's equal to, what's our a? 3. The first term plus n minus 1. Our n is 46 minus 1, and then our d is our common difference. 5 minus 3. 7 minus 5. 2. So our difference is 2. Type it in. 3 plus 46 minus 1, or you could say 45 times 2. 93. So term 46 is 93. What's the 3?
3 plus 46.
It's this formula, right?
Yeah, I know, but wouldn't it be 46?
Well, I just did this in my head and said that's 45 times 2, right? Same thing as 46 minus 1. So you do 3 plus 3 stands for the first term.
Okay.
Good question. Any other questions? Okay. Awesome. Do 11 through 20 questions. Okay, so now we know that an arithmetic sequence is the same exact number will be added or subtracted between each term, right? Every time it's going to be the same, right? We're either going to add 2, add 2, add 2, or we're going to subtract 2, subtract 2, subtract 2, right, everybody? It's always going to be the same between each term. So, for example, we have 2, comma 4, comma 6, comma 8. So we would always do 4 minus 2, 6 minus 4, 8 minus 6, that's 2, right, everybody? So we were adding 2 to each term. Okay, so now in something like this, it says, what is the missing term of the arithmetic sequence? So now we're given 3 consecutive terms, but we're missing the middle one, right? So this is a way of thinking through it. Let's think about it. Won't we have, so between 3 to 9, won't we have to get there adding something and then adding that same thing here? Right? Because it doesn't have to be the same every time you add. Okay, so we've got to figure out, well, what are we adding to get to 9? It's got to be added evenly. So let's think about this. Let's figure out the full distance from 3 up to 9, and then divide it by 2. And that wouldn't that be the amount we should add? Okay, so let's do that. Get your calculator. Go 9 minus 3. That would be the distance between 3 to 9, right?
Yeah.
So we're going from 3 to 9, we've gone 6 numbers, right? We've gone up 6 units. So think about it. If we have to split that evenly between 2, what do we do 6 divided by 2? 3. So wouldn't we be adding 3 each time? So 3 plus 3 is 6. Then 6 plus 3 is 9. Do you see how we got there?
Yeah.
Okay, that's one way of thinking through it. So let's do another one. So this time we have 4 consecutive terms, which means 4 terms, one coming right after another, correct? Now, how many units are between 3 to 12? Let's figure that out. So 12 minus 3. 9 units. But doesn't that have to be split evenly this time over 1, 2, 3? So you'll take that 9 units divided by 3. It's 3. So we'll be adding 3 each time. 3 plus 3 is 6 plus 3 is 9 plus 3 is 12. So that's one way of thinking through it. Is everybody good with that? Now my book, gives a formula. To me, that's the math behind why that makes sense. There is a formula, though, however, for it. That works a little differently. Because let's think about it. I do want you to think about this, too. Okay? So if you think about it, if we wanted to find the middle term between 15 and 59, if we found the midway point, wouldn't that be the midway point between 15 and 59? Wouldn't that be the number that we're talking here in the middle? So how do you find midway point? Isn't that average?
Yeah.
The average between the two? Okay, so instead of figuring out how much you're adding each time, you could just find the average of the two numbers, and that would be the number in between, right? So you could do it like that. You could do 59 plus 15. That's adding up how many units total, which is 74. We want to know what's the halfway mark, because wouldn't that be halfway, then halfway? Added evenly. So divide that by 2. So that's why it's x plus y divided by 2. What do you get? 37, right? Which makes sense. The way we thought through it before was we said how many units? So we did 59 minus 15. That's 44 units divided by 2. So we'd be going 22 units each step. So 15 plus 22 is 37. 37 plus 22. So you can think through it however you want. Does that make sense, everybody? Yes.
So would the number that you divided by be the number of...
Yes. Good point. Yes. The number, yes. It would. So once again, that's called a mean, which means average. So the arithmetic average will give you the middle term of any 3 consecutive terms. So you can do it either way, however you want to think through it. Okay? Okay, so do front and then do 41. Actually not new. It's not new to us, but then I'll let you finish it up, and we're not doing the whole worksheet. So you'll be able to finish this by the end of class. So it says, I'm doing problem number 35 on the back. Read the directions. It says, find the arithmetic mean a sub n of these given terms. So first of all, number 35, we're given a sub n minus 1 is equal to 5, and a sub n plus 1 is equal to 11. We're asked to find a sub n. So I want to remind you, in a sequence, a sub n minus 1, comma, a sub n, comma, a sub n plus 1. Isn't this just mean the term we're talking here? Doesn't this mean the term that comes before the previous term? And this is the term that comes after this term, right? So, if we're given a sub n minus 1 is 5, we have 5, comma, a sub n, comma, and a sub n plus 1 is 11. And now it says find a sub n. Wouldn't that just be like what we were just doing? So I would just find the average of those two, because that will give us the middle number between 5 and 11. So we'll do 5 plus 11 divided by 2, right? 16 divided by 2 is 8, so that's 8. So now if I ask you, what's the common difference when you just go 8 minus 5 and 11 minus 8? Should check it? Okay. Questions?
Do we have to do the difference in between the two or just find the number?
No, I'm just asking besides the point. No. Okay. 35 through 40, that's all that's required. So anything I assign, so the whole front page, right? Then pretty much 35 through 41, because I also assigned 41. So up to 41 is what is due on this worksheet.